DAVOSS is a project funded by NATO Science for Peace and Technology program. The aim of the project is to overcome the limitations of current monitoring systems based on unmanned aerial vehicles. This is achieved by introducing network softwarization within a multi-layer UAV architecture.
The NATO Science for Peace and Security program promotes dialogue and practical cooperation between NATO member states and partner countries based on civil scientific research, technological innovation, and knowledge exchange. In its 60 years of existence, the SPS program has continuously provided opportunities for hands-on scientific and technological cooperation. It has also fostered knowledge exchange, for example, by supporting training courses and workshops. In doing this, it has contributed to maintaining NATO's technological edge by supporting research on emerging security challenges. In fact, the SPS program's activities are dealing with priority topics such as counterterrorism, environmental security, defense against CBRN agents, and security-related advanced technologies. The DAVOSS project is an excellent example of the SPS program's innovative work on advanced technologies, particularly in the field of autonomy. With the development of a multi-sensor cloud-based architecture, the scientists involved in this project have demonstrated the SPS program's ability to deliver security-relevant activities with tangible results.
The DAVOSS project perfectly fits with NATO's 2030 objectives on innovation, emerging and disruptive technologies, and resilience. The project makes use of unmanned and autonomous systems, UAVs, balloons, and other vehicles for monitoring, reconnaissance, and crisis management missions. The project developed a dynamic and adaptable architecture able to extend the coverage of current monitoring networks and eventually to provide connectivities in areas affected by major disruptions. This can help in enhancing resilience, civil preparedness, and in making NATO's and partner nations' critical infrastructures more robust. This project benefits from cooperation between teams of researchers in Italy and Israel. They brought to the table a mixed set of skills in the field of communications, robotics, information technologies, as well as an interest in working together to develop new technological solutions.
The architecture proposed by DAVOSS consists of a swarm of drones that are used to bring connectivity and services to ground users and stations, and one or more high-altitude platforms or low-Earth orbit satellites that are used to maintain connectivity and continuity of the services. Network function virtualization is used to enable orchestration and replication of the provided services in order to maintain reliability and availability of all the services that are provided by the DAVOSS solution. Examples of the services provided by DAVOSS include 4G, 5G connectivity, automated image recognition to detect humans and cars and bicycles, for example, as well as localization of Wi-Fi signals and sensor data acquisition.
One of the Technion DAVOSS project was researching and building a prototype of a drone-based mobile gateway. In this project, the drone flies between the sensors and communicate directly with each of them to collect their data. There were many challenges, the most important of which was to design an optimal drone path. This path should allow the drone to communicate with every sensor node by being at the correct location during the correct sensor duty cycle time. This route is then iteratively improved based on the gateway transmitted power and on the RSSI from every sensor.
In order to demonstrate the feasibility of the DAVOSS solution, we performed extensive testing in the area of the Trentino region, and especially in our drones lab, which is located in the area of Pergine Valsugana, where we have a dedicated infrastructure.
My contribution in the DAVOSS project was the feasibility study of the use of small satellites to provide virtualization of level 2 network functions, namely iterative LTE turbo decoding, so to lighten drones from computationally intensive and energy demanding processing tasks.
The entire DAVOSS solution is designed to be compatible with ETSI Mobile Edge Cloud solutions, as well as recent releases of 3GPP 5G standard. And we might say that it represents one of the first solutions in the framework of the evolution of 5G towards 6th generation.
In 2015, the United Nations have established 17 goals for a sustainable development of the world. The main objectives are to reduce inequalities, economic, educational, societal, to increase economic growth and innovation, together with ensuring sustainability and environmental respect. The objectives have become the pillars in the design of future generation networks, the ones that we call 6G. These networks will be always available in any part of the world, ensuring the reduction between countries and areas of the digital divide and their inequalities. Moreover, it will target sustainable development and the creation of new markets and industries such as the tactile internet, telepresence and digital twins, and industrial campus networks of robots. The DAVOSS project started in 2018 and aimed at creating 3D network architectures and infrastructure, considering the combination of satellite, aerial platforms and terrestrial platforms, in order to guarantee network scenarios that are capable to provide connectivity in emergency scenarios for disaster response after earthquakes, or to provide network availability every time, everywhere, to ensure this reduction of the digital divide between rural areas and urban areas.
We plan to provide global connectivity to the Martian surface for future astronauts and even machines by exploiting the knowledge gained from the BBU splitting development in the context of the DAVOSS project. The lower drag force experimented by objects on the Martian orbit with respect of being on Earth will hopefully allow us to lower the altitudes and virtualize 5G remote unit, centralized unit and distributed unit functions thanks to drones, weather balloons and the constellation of CubeSats involved in the network communication. The preliminary analysis suggests the feasibility of placing satellites into stable, very low Mars orbit to respect latency requirements while maintaining a considerable communication window.